6, 7, 8, 9, 10. Okay, from that first video, I forgetted that I had an example. I said before, this is just a calculator button stuff right here. So type that in the calculator and you should get about this answer. And I have an example for you to pause and try to see if you understand that. For example 2 right here. So there's your problem, 5 to the x equals 12. Pause that and try to find the answer. Okay, you should have found the answer was about 1.544. Okay, how did you do? Let's go on to the third example. Now the third example is much more difficult and much more in depth. Okay, it starts off with this other property. It kind of makes sense. If these bases are the same, then their exponents must be equal. And if you think about it, the same thing works for logarithms because a logarithm is an exponent. Do you guys remember that? A logarithm is an exponent. So if I have a log base 5 of this thing equals log base 5 of this thing, what does that mean? Those two things, the arguments, in other words, their quantities, must be equal. So that's what you do right here. The same thing we did up above, just take the arguments and set them equal to each other. Same thing we can do here. I got 2x and that equals 8. Now how do we solve that? Well, divide both sides by 2, and so you get x equals 4. But it gets a little more difficult when you have x's like this, if you have quantities on both sides. So you're going to see, first off, when you have variables up in the exponents on both sides. Oh, you can't see that. If you have variables in the exponents on both sides, you're going to need to take the log of both sides. So the log of 3 to the x plus 1 equals log of 5 to the x. And then we use the power property to bring the exponents down in front. Remember, the power property just jumps in front. Use this as a quantity. The x plus 1 is a quantity. So it's x plus 1 times log of 3 equals x times log of 5. Now this is a quantity, x plus 1. Log of 3 is just a number, like 5 or 6 or something like that. So you have to distribute. X times log of 3 is just x log 3. And then 1 times log of 3 is just plus log 3. Over here we rewrite the x log 5. Now rearrange. When I say rearrange, you wanna, it's like having 2x plus 4 equals 6x. How do you solve that? You get all the x's on one side and all the constants on the other. So I would subtract 6x over here, negative 4x, and subtract 4 over there, negative 4. You see that? So I have x's on the right side, x's here, and I have a constant. So I'm going to get all the x's on this side. So x log 3, and this is a positive number, so when I bring it to the left, it's going to become negative, minus x log 5, and then bring this log 3 to this side, equals negative log 3. Okay? So then this is, you have to factor the x out. There's the greatest common factor here of x. I'm going to factor the x out front. What's left of each of these numbers? It's log 3 minus log 5. And that equals negative log 3. Okay? The same thing we do over here when I have a number in front of the x, divide by that number. This is a number, so I'm going to divide both sides by log 3 minus log 5. Okay, now this is a difficult computer. This cancels out, so you have a computer. This is a difficult calculator problem. I'll have on the written notes. I don't want to take time right now, but you'll figure out what the answers with that in the calculator. But I do have another example ready for you to try. To pause the video. So let's see, let's put that right there. I want you to pause and solve that. Okay, you should have paused and solved it. The answer to this one is about 14.57. How did you do? Look up on the pictures of the notes on OneNote to find out what the answer to this one is. Okay, that's it for this video.